This next podcast will deal with sex-linked traits. Sex-linked traits behave much the same as the codominance problems that we did, except a sex-linked trait is a trait that's located on the sex chromosomes. Now remember that in a normal human karyotype, we find 22 sets of autosomes, and we find one set of chromosomes which we call sex chromosomes. So in our females, they would have an X and an X, and in our males, they'd have an X and a Y. A sex-linked trait is a trait that's located on either of the sex chromosomes. Most sex-linked traits are carried on the X chromosome, mainly because the X chromosome is much larger and there's not really a lot to the Y chromosome. So if we look at an example, eye color in fruit flies is primarily sex-linked. And so our female fruit flies would have two X's and a male would have an XY. And on the X chromosome is where we would find that trait. So you can automatically kind of start to see or make out that if we have maybe a loci for a particular trait, like eye color, that females will have two possible alleles for the trait. I mean, they could be homozygous dominant, but they could have two possible. Males, on the other hand, won't. They will only have one or the other. So when we do sex-linked problems, one of the things to keep in mind about sex-linked traits and doing a sex-linked problem, much the same as our codominance, is we have to account for males and females now, because obviously they're going to be different. So if we were to look at eye color in fruit flies, we know that eye color red, we know that eye color red is dominant over white. If we were to cross a red-eyed male, so again, the first thing I do is I write the X and Y because I know it's a male, and then he is red, so he's got a big R. He has nothing on the Y because it's a sex-linked trait on the X chromosome. Questions will usually tell you if they're sex-linked on the X or the Y, and I will tell you right now, none of our questions will be on the Y. The Y, there's really not much to it. A female that is white, well, she's going to be homozygous recessive. Now, the neat thing about this cross is when we actually do the cross on a Punnett square, something really unusual happens. And for those of you that have done the fly lab, what you will find, and what you should have started to find, is that in your sex-linked problems, when you did them, that after the very first cross in your F1 generation, you should have noticed that for sex-linked traits, the traits switched. So if I look at this cross now, I started in my parents, so this was my parental, and these are my F1s. The genotype for my F1s will be, in terms of females, will be 100% X big R, X little r. It's 100% because it's two possible genotypes, this one here and this one here, out of two possible genotypes for females. For males, it's 100% X little r Y. So that's the genotype. Phenotype, again, for females, they will be 100% red-eyed. And for males, they will be 100% white. And that's what you would have noticed in your fly labs when you cross them, that the traits do switch. You will have several problems on sex-linked traits to work on. They operate much the same as codominance. But this slide here, the last slide that we'll sort of leave with, is the idea of carriers. When we look at sex-linked traits that are diseases, diseases like hemophilia, women are carriers and men have the phenotype more often. So this is looking at the royal family tree. And This is a pedigree. The next lesson after this will be dealing with pedigrees. And the one thing that we find is that oftentimes females are carriers. Queen Victoria here for hemophilia would have been a carrier. A carrier means that they do not exhibit the trait in question or the disease in question, but they do carry an allele that could possibly transmit it to their offspring. And more often than not, with sex-linked traits and sex-linked diseases like hemophilia, it's the sons that sort of pay the price because they only get their X from their mother. So Queen Victoria had a 50% chance to pass it on to her son. Or actually, we'll look at Alexandra here. Alexandra had a 50% chance to pass it on to Alexis. It didn't matter the genotype of Nicholas II of Russia because he does not contribute the X. He contributes a Y to his son. So Alexandra, who was descended from Queen Victoria, who was a carrier for hemophilia, passed the trait on to Alexis. Hemophilia is the inability of the blood to clot. Prince Alexis actually didn't live very long back when he was growing up because he would have had blood clotting issues, and medicine just wasn't the way it was today. So that's a sex-linked trait. You should have enough sort of information to go ahead and do sex-linked problems now.